Today I am going to present the location service inside webOS Auto. The contents include the integration and the integration. Introduction will include the overview of the location service and the features supported in the location service and the service design, location service design. Overview. The service provides the geolocation information from various positioning sources such as GPS, network positioning system, and the location-based service. So, the location service allows the application to obtain a periodic updates of the device's geographical location. Location service provides APIs to application layer for getting the geo information. So the geo information is basically all kind of the geographical data information of a user or a device in a different mechanism way. The location service provides APIs to the application layer for getting the geo information. It's basically applications can access the location service through the Luna service APIs. Location service from the various positionings are as follows. Location update based on the GPS, location update using the network positioning, location updates using the geocoding and reverse geocoding, and location updates using the mock data. Now, location update based on the GPS is basically we are accessing the GPS data or the geolocation data from the GPS hardware which is connected to the webOS target. Either it could be AirPlay or Auto. Location updates using the network positioning system can be accessed by using the network provider in the location service by using the HTTP service or by starting the HTTP request actually by using the Wi-Fi access points. Location updates using the geocoding and reverse geocoding can be achieved by using the location-based service, that is LBS, by using any of the third-party APIs. Like in our case, actually, we are using the Google APIs for getting the geocoding and reverse geocoding. Location updates using the mock data is the concept where we are trying to take the offline data by using mock facility. This can be achieved using the network positioning system or the network routing address as well as from the actual GPS hardware. So in this case, we get the data by setting the coordinate, generate the NMEA data, and that we can use it as part of our location service to parse it and periodically send the information using that file. Overview, context diagram of the location service as right here. Now the applications would access the location service for getting the geolocation services, basically the location services, by using the geolocation services or the GPS hardware. So the geolocation services would be able to achieve by using the network positioning system. GPS hardware anyway, we can access it directly through the target. Now applications would be like maps, navigation, etc. Location service is basically from the webOS. And other things are GPS hardware and the geolocation services. These are all treated as an external entities for the location service. Now, the location service has been decomposed. Context diagram has been decomposed to get a better understanding. Now, the applications would request or call the APIs which are provided by the location service, and the location manager is the higher hierarchy component which resides in the location service, which is majorly includes two things. One is the position provider and the LBS provider. So the position provider component will again be divided into two things. One is a GPS position provider, which actually works on the actual hardware, and the network position provider. Now the network position provider would be able to achieve by using the network request manager, which is the common utility or the common entry interface to provide the HTTP request and the response, or initiating the HTTP request and the response basically. So now the location service also has an LBS provider which will talk to the network request manager, because even the location web-based service would also require the same HTTP service, HTTP request and response for initiating and terminating the geolocation services. Hence, it talks to the network request manager as well. And the network request manager will talk to the outside world, which is geolocation services, whoever provides. In our case, we are using Google as for the geolocation. Now, when it comes to the hardware, GPS position provider will interact with the NIX module. NIX is a separate entity again, which we will explain a little later actually in the later slides, but I'll just give an overview of here. NIX module is an interface for the hardwares which are connected. There, the functionality of any hardware can be controlled, any device can be controlled in the NIX layer. In our case, the NIX GPS module has been implemented as part of the NIX to control or to handle the GPS functionalities. So by using that GPS hardware, we can get the geolocation information to the NIX module, or we can also generate the mock data, NMEA data to the NIX module, and NIX module will have the corresponding callbacks and the parsers actually. Based on that, this will reply back to the position provider to get the information to the location service. Now, so this is one part of the location service, and there is another part of the location service is connection state observer, which will talk to the connection manager. So this guy is mainly responsible for keeps track of the connection status, Wi-Fi access point, and the status change notification. All these information would come to the connection manager. Connection manager would indicate to the location service. In this way, so now all these components has been explained a little briefly. So the location manager loads or unloads all position providers and location based services. So basically it loads or unloads all these. The position provider provides the common interface for both GPS position hardware and the network position provider. LBS provider provides the location based services using the Google Web Service APIs, as I discussed or as I explained earlier. GPS position provider provides the location satellite info from the USB GPS device. So basically this is whatever the GPS hardware is connected to the target. So that this class is mainly responsible for getting the information, as this guy is registered for the callbacks of the NIX module. To get that, network position provider provides the location by using the Wi-Fi access points, as explained. So the connection state observer keeps track of connection status, Wi-Fi access point, and the status change notification. GPS NIX module is a software module that implements the functions for actual control of GPS device. Overview of the location service API. So the API usage example just explained 2, which is basically major APIs which always keeps on using, majorly used actually in the location service. That's a get location update using the get location updates. So this is the format of sending or calling a Luna API, Luna service, and the component name and the get location updates is an API along with the handler as GPS. We'll pass that handler as a GPS. Only subscription response is provided. This will be available only when the location data is available. So if we want to get the subscription response periodically, then we have to subscribe this, so that actually periodically will keep on changing, or any changes in the state, it keeps on updating the location. Now in this actually subscription response is like this: return value, speed, longitude, error code, horizontal accuracy, vertical accuracy, direction, timestamp, altitude and latitude. All these information would get as part of the response to the get location updates. The similar way actually we are getting the response for get reverse geocoding using get reverse location. So this is what the API, and we'll pass that as the latitude and longitude as an input, so that actually we'll get the response to corresponding to that. Features. What are the features which are supported in location service? Supports the geolocation. What do you mean by geolocation? Geolocation refers to the identification of the graphical location of a user or a computing device via a variety of data collection mechanisms. Typically, most geolocation services use the network routing address or internal GPS device to determine the location. Internal GPS is basically whatever the GPS device which we connect to the target. And apart from that, support of geocoding and reverse geocoding. So what do you mean by geocoding? Geocoding is the process where it converts the address into spatial data and associate the exact geographical coordinates for that address. It is used to graphical information system to help find the coordinate of a place or address. And then what is the reverse geocoding? Reverse geocoding is the process of converting a location as described by geographic coordinates, that's mean longitude and the latitude, to a human readable address or a place basically. And the third is it supports for anemia devices. Anemia devices, we are going to explain it in the further slides, where it is used for the mock data. By using the anemia parser, actually we collect the data and generate the anemia parser, the anemia file, and we have a parser to parse the anemia file, and we will pass that to the location service as a response to provide the location service. Now, ability to maintain the cached geographic geolocation information. This is one of the advantage or added feature to the location service. For easy extensibility, extend the support of different GPS hardware using the NIX model. So whatever the different vendor of the GPS hardware needs to be thought of using it, then actually the NIX module has to be changed to provide the corresponding APIs which are provided by vendor GPS hardware. So this is one of the easy extensibility provided as a feature to the location service. Now, service design. So service design includes the architecture and the component diagram and the interfaces provided by location service. Architecture. Now the architecture includes three layers: applications and the service layer and the model. So basically location service sits in the service layer, and the applications like maps, navigation, health apps, cycling, settings, all these would accept the location service for different usages. So these applications will talk to location service through the Luna bus, as location service is a service layer. It's a software component in the middleware which will get registered to the Luna API, so that it provides, or the Luna applications through the Luna bus, actually anybody can call the APIs of the location service. Now, and the third part is modem, actually, which is kernel, which is kind of a hardware related stuff where the GPS engine and all can be handled through that USB interface of GPS hardware. Now the location service, when it comes to the location service in the service layer, as we explained earlier, the location service includes majorly two parts, position and the LBS. And the position is again further divided into position providers. So the position provider is again having a GPS based position provider and the network position provider. And the location manager will also have this location manager. We have kept it for the easy reference to indicate that. So this and this both are same actually. So once the location manager, for the LBS, it will go to the LBS provider. LBS provider will talk to the request manager, network request manager. Here the position provider will have a different GPS and the network. GPS actual hardware usage will talk to the GPS NICs module, and the GPS NICs module will talk to the hardware GPS, or it can be a mock data also. Through using that QMI, actually it will talk to the kernel part, which is basically actual hardware is connected to the webOS target. Now when it comes to the network request manager, is basically used for the network services or the Google geolocation services. As of now, geocode, reverse geocode, and the geolocation has been implemented as part of the location service. So we can call these services by using the LBS. The geolocation can be used by using the network routing address. So as simple, we have explained the legend actually with respect to this architecture, where the Luna calls would be indicating that as part of, we'll talk to the Luna service, and this pink color line would be indicating that the API calls, as this is one of the location service. Inside location service, all these components are talking to each other. This one service, and the components or the modules are talking to each other through the API calls. Now, extendable modules is basically a GPS NICs model where any other functionalities or any other features to be provided as part of the location service, those needs to be implemented in the GPS NICs module first, so that that can be utilized in the location service. Like for example, the geofence, add geofence area and remove geofence area, where we need to implement, if the vendor GPS, hardware GPS is supporting those two functionalities or those two features, those callbacks needs to be implemented as part of the GPS NICs module, so that those callbacks would get registered to the GPS position provider in the location service, so that would get the response back to the location service. So similarly, actually GPS vendor module, this is actually for getting the actual GPS data from the vendor GPS, and GPS mock data by using the NMEA data. And the web service module is, anyway, as of now we are using the Google actually, but third party actually, whichever we wanted to modify it, we can extend it by changing the vendor or by changing the cloud service anyway. Now the location manager, I just explained actually each module as loads or unloads all position provider and location based service provider. Position provider provides the common interface for GPS and network positioning system. LBS provider provides the location based services using the Google Web Services APIs. GPS position provider is provides the location satellite info from the USB GPS device. Network position provider provides the location by using Wi-Fi access points. Connection state observer keeps track of the connection status, Wi-Fi access point, and the state change notification. GPS next module is the software module that implements the functions for actual control of GPS device. Now, the component diagram of the location service based on the features of the usage actually which we are looking for. Now, geocode or reverse geocode information using LBS are the location updates and the mark location updates we wanted. 3 different categories of the features actually which will request the GPS position provider, network position provider, and the LBS. But here the LBS and the network position provider, anyway we use the network request manager directly for the HTTP query or the HTTP request and the response. So internally, so that actually it will talk to the HTTP query for the supporting dips or the network query. So once any changes or any responses would be answered to the connection manager, and the connection manager will talk to the location service or indicate basically network state or any changes in the notification, basically if any changes in the network connection. So in this case, geocode updates will get it done by LBS, and the location updates we have 2 different things again as we explained earlier. Network position provider also we can get the location updates, and the GPS position provider also we can get it. But the GPS position provider we will get the information from the actual hardware or the vendor hardware which is connected to the target through the next module. But the network position provider anyway through the network request manager. So similar way mock is also same by using the network position provider or the GPS position provider with the actual hardware. Decides API overviews. Decides the type of location service provider based on the request parameter. Once a suitable location service provider is selected, the service uses the location service provider to construct the position fix. So webOS uses the following location service provider for position fixing like GPS, WPS, geocoding or reverse geocoding. Prerequisite basically needs a Google Geocoding API key for this requirement. Mock enable to test the location feature with the fake information. Interfaces. API list, actually we have listed the APIs which are supported as part of the location service. Get anemia data, gets the anemia sentence from the GPS server. And get reverse location transforms a given coordinates, longitude and latitude into a partial address. Get geocode location transforms a given street address or other description of a location into a coordinate, that's longitude and latitude. Get all location handler. Get a list of all available location handlers along with each handler's sub attributes including name and state. Get GPS status. Gets the current status of GPS engine used for notifying device users that the GPS engine has started or stopped. Set state enables or disables the location service provider in the settings menu. And the get state gets the current state of the given handler. Application settings can use this update location settings. Get location handler details. Gets the details of the given location handler. Get GPS satellite data. Gets the satellite information. And get location updates. Request a single location fix based on the given criteria. If the subscription value is set to true, it requests for the continuous location fixes on periodic basis. And the geofence. The geofence add geofence area and remove geofence area. So these 2 APIs API calls has been provided from the location service, but the functionality has not been implemented yet. So only we can use these APIs just to get the dummy response. So adds a geofence area for a given location based on the position, longitude and latitude and a given radius. Geofence or remove geofence area removes the given geofence area added by the add geofence area method. Mock enable, mock disable or set location. Enables the mock and disable the mock for a given provider. It could be a network position provider or it could be a GPS position provider, and disables the same. Set location sets a mock location for the given provider. Integration. Integration would include the low-level design and integration. Low-level design. Location service architecture consists of positioning service and the location-based service. As we explained, it will be two things. One is position provider and the location-based service. Each submodule in the location service has the implementation of a Luna request. Communication is through the Luna request. Position provides the implementation to handle position related to Luna commands. The LBS provides the implementation of location-based service related to Luna commands. Architecture with the low-level design. Location manager is basically load or unload all position providers and location-based service providers. Gives an access of the position or LBS web services to the Luna interface layer. Maintains a list of position or the LBS web service providers. Now when it comes to the position provider, provides a common interface as we explained earlier for porting or adding a new location provider which gives the location information. Currently standalone GPS and the network position providers are present. Network position provider web service is extended to new web service provider, extendable actually. Network provides the location by using the Wi-Fi access point, that's a MAC address of the Wi-Fi node. GPS provides the location, satellite info from the USB GPS device. Now when it comes to the architecture of the location-based service provider, this provider determines the location based on the nearby of the Wi-Fi access point. Operation of this provider may require a data connection. Any new web location service like geocoding or reverse geocoding can be extended by implementing in the map service interface. Each location web service provider has the individual implementation of any of geocoding or reverse geocoding. Connection state observer provides the platform related data which is required by location service like network connection status, Wi-Fi access points and the status stream notification with those access points from the connection manager. The network request manager, as we explained earlier, component to create and terminate the HTTP request for the location service, accepts the request from the network position provider as well as the location based service for initiating and terminating the network transaction. It provides the results or error back to the requester. Now, we came to the actually low-level design of the NICS module for GPS basically. webOS GPS hardware abstraction layer. NICS hardware abstraction layer consists of a uniform client API and the device modules. The uniform client API consists of a public API that is used regardless of the device type and the device module. API that provides the control functionality of the device type. A device module is a software module that implements the function for actual controlling of each device. Like in our case actually, NICS device GPS device type is used for a GPS. NICS device open is called from a platform an object is created by loading an appropriate device module. Like for example, load of GPS module. NICS device open is a call basically which we have just given an example, which includes the GPS name as an input and then configuration, chipset ID and along with the system GPS system. This is the handler kind of stuff. release the object of the GPS module, we'll use that handler again to release that. Extending a support for different vendor GPS hardware can be achieved through implementing the same in Nix module. Basically, to extend a support for different vendor GPS, Nix GPS.h needs to be implemented. Why? Because all these Nix interface APIs has been defined globally as part of the Nix_GPS.h. That's a part of the Nix library. And the reference has been given below for the Nix GPS actually as part of the GitHub. You can go through that. So as we explained here, the Nix GPS APIs, Nix GPS.h will include the Nix interfaces as well. Some of the interfaces we have listed down actually. So the Nix module interface are as follows. This is actually Nix device open and the Nix device close. This is basically opens the device for controlling and closes the device for whatever we were controlling. Nix module GPS interfaces are as follows. That is basically init, start, stop and cleanup. Init is basically opens the interface and provides the callback. Opens the interface and provides the callback routines to the implementation of this interface. Start starts the GPS engine for navigation, stops the GPS engine. Cleanup is basically closes all the interfaces with the callbacks which are opened during the init. Nix module callbacks for GPS. Now Nix GPS location callback provides the location updates. Along with that, Anemia callback is basically GPS Anemia callback provides the Anemia location updates. So the simple sequence diagram for a success case has been drawn to get the GPS data from the GPS hardware. Here from the application, get location updates with the subscribe false. We are not subscribing it for the periodic data. We are just sending that as a handler as a GPS to the location service. Now the location service boundary you can see here actually. Location service has the GPS position provider and the GPS Nix interface. And apart from that, the Nix module actually and the GPS hardware. When the GPS position provider init has been initiated, it opens the Nix GPS module to the GPS Nix interface. It calls this Nix device open. You can recall this actually in the previous slide. The Nix module interfaces actually. Nix device open will be called to the Nix module and opens the Nix GPS module. And the response will be communicated back in the similar way to the GPS position provider. Now, once the GPS position provider has got the success for the device open, then the interfaces from the Nix module or the callbacks to get the information from the GPS hardware in the Nix module. Initializes the callbacks and the Nix GPS init, as we explained in the previous interfaces actually for the Nix. When we call this Nix GPS init, will register for all the callbacks, initiates the callbacks. So register the callbacks here for the hardware to get the location data. The response will be given, register response of the Nix GPS unit, callbacks initialized, and the response for the position provider init will be provided. So this is how to get the data actually. Once this GPS is started, actually you can get the location updates easily because the register callbacks has been registered. Now to start the GPS engine, start the GPS, Nix GPS start and the location data, GPS location callback, CVs, and update the GPS data, send the location update. And the response of the get location update would be reached to the application. So next we'll stop the engine from the location service to the GPS Nix interface, and this will call the GPS stop, Nix GPS stop this, and the response would get it and would be communicated to the location service as it is. Next, integration. Integration would include the files and directories. service configuration, service setup. Repo for the location service is webOS OSC com.webos.service.location. Source folder of the location service would include the following categories based on the service type. Basically, this would get the LBS and the handler. LBS folder would include the files providing support for location-based service. Handler would include actually GPS and the network. GPS folder would include the code corresponding to the GPS service from the hardware using the NICS interface model. The folder includes the configuring GPS, GPS positioning provider.cpp, GPS service config.cpp, GPS WAN interface.cpp, etc. Network folder would include the files for providing the support for location service using the network positioning system, and the corresponding file would be network data.cpp and network position provider.cpp. Mark folder admin would provide the location service, offline service, which would be collected using the network, and the same data can be utilized. The files would be GPS marklocation.c and the marklocation.c and network marklocation.c. Okay, next is a repo for the NICS module is actually webOS Auto for NICS modules. In the NICS module, we are mainly concentrating only on the GPS data, which corresponds to the GPS data or the GPS functionalities, which has been implemented as part of the GPS. So GPS handling functions in the NICS model for location service, which include majorly parser implementation and parser thread functionalities. Parser enemy.cpp is the implementation. Basically, this is the one implementation for the enemy data parser. Is one of the parser actually. Now, source folder would include GPS to support the location service. This folder includes configuration for GPS, so GPS service, so parser hardware, parser interface, and parser mark parser, parser thread pool, and so on. Parser in MIA would be able to parse the data which has been collected the coordinates from the mark file or GPS hardware. So the location service can be configured as follows. This is with respect to the service configuration. So the service configuration is based on again whether we are using the GPS hardware or the network positioning or the LBS. Now, if the GPS hardware needs to be used for the location service, then the GPS hardware needs to be connected and live data will be captured based on the geolocation. GPS has the configuration file in/etc/location/GPS config data conf in source, which is mainly meant for configuring the port to connect the GPS hardware to mentioned port. Basically, this conf file would include the port is equal to /device/tti USB 0, where we are connecting our GPS hardware in the webOS target. GPS config file, which is available as part of the build in/etc/location/GPS config.conf would be available in the repo com.webos.service.location under the files /GPS config.conf. Similarly, actually, if you want to use the network positioning system, then the network positioning system will use the geocoding data provided by one of the Google Maps platform APIs. So LBS positioning uses a geolocation key using which is defined in the geolocation.conf, in which Google API can be added at the runtime. Geolocation requests are sent to the URL actually. This is the URL to get the API key for the Google. Now mock is, as we know that actually it's a fake data which we are collecting through any of the website. Now in this case actually we are using the Anemia data, so we are generating the Anemia file actually. Anemia data has been captured, location will be used for location service processing. Anemia data can be generated by using this site in a browser and selecting multiple points in the map. Mock has the configuration file in same folder actually, so etc location mock.conf, which includes the flag for setting the mock and setting up the latency. Basically, these are the parameters. Mock is equal to false, indicates that actually mock is disabled. Mock is equal to true, which indicates that mock is enabled. Latency is equal to 2. Mock config file, which is available as part of the build in this, would be available in repo com.webos.service.location and files/etc/mock.conf. Similarly, service configuration for the LBS, location-based service. Location-based service has the following config file, which is in /etc/location wsp-conf, which includes WPS name and features supported by the same WPS and corresponding URL, which can be added at runtime. wsp.conf file, which is available as part of the build-in /etc/location wsp.conf, would be available in the repo, same in the location com.webos.service.location under files etc wsp.conf. Prerequisite for using this Google Maps platform API is setting up the geocoding API key as given in the link. So we have to set up the key actually before using the Google APIs. In this case, present features are supported from the WPSR geocode and reverse geocode, which has been implemented now as part of the webOS location service. WSP-conf has the following fields for service configuration. Example, that is in the config file actually for the WSP-conf, which includes the WPS name is a Google actually, which we are not going to use it, just a representation actually, what we are going to, what the client or what is the service which we are going to use it. And the API key is a blank actually, which we have to generate and update it here before using the service. And the services as of now features geocode and the reverse geocode is supported. This is the URL for using that APIs. Service setup. Location service includes 3 different setup as below. One is GPS hardware, another one is network positioning system, and another one is LBS actually. Now the GPS hardware, where do we connect it actually? GPS hardware need to be connected through USB port to make use of hardware. Please find the GPS connected to auto port in the below picture. This is the GPS hardware actually which we have connected, which we have directly connected here in the below port. Service setup for the mock. Mock data can be generated by using, as we discussed, generated from the anemia.org. As simple as it is actually. Open the anemia.org, select 3 coordinates here. Anemia data can be generated as shown below in the diagram. Select the coordinates and generate the anemia file as shown below. Select 3 coordinates and generate the anemia file. Copy the GPS anemia to /media/internal/location in the target. Use it. Before using it actually we have to rename it from the anemia file to gps.anemia, random file name to gps.anemia. Network positioning and location-based service. Anyway, system uses location-based service can be achieved using the geocoding API by key setting up through this. So these are the references basically which anybody wants to go through that location service. So these requires actually location service and the Nix module and the Nix library, and these are the references for creating or generating the API key to use the Google APIs, and sign up actually for Google Maps to use the APIs. And the location service overview and the APIs basically for this is webOS.org docs, where you can get the com.webos.service.location and the anemia data generator as just shown before the slide to generate the anemia data. So this is all about the location service in the webOS. Thank you.